Hey everybody, this is Larry, this is me going with Q3 of the weekly contest 414, reach end of array with max score. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. I think this one's way tricky to get correctly. I mean, if you look at the top scores, a lot of people got it, well maybe not this, but well actually like 2 minutes. People got it like way fast, but I actually end up taking 8 minutes or so, a little bit less. You can watch me solve it live next, of course. But here I'm going to not just explain the solution, but explain my thought process, right? Because look, anyone can read the solutions somewhere, but my thought process is unique to this video, so stay tuned. But yeah, so honestly, the first thing I noticed is that it is n is 10 to the 5th. So I knew that if it was dynamic programming, obviously it cannot be an n-squared dynamic programming. I was thinking along the lines of playing around with an n log n dynamic programming or O of n dynamic programming with a max q type or like a mono q type thing. I think there is a solution where it is something like that. I could be wrong because the idea here, there is some idea, and I don't know how. I mean, I'm not going to spend that much time on it because I didn't solve it this way, and there is a much easier solution. But it is something that I think is worth kind of just thinking about just a little bit at your free time for upsolving, because I could imagine that there'll be a much tougher problem that uses some of this idea, right? But the idea here is that, okay, the idea here is that, okay, well, for every number, so you have like, you know, for every number, as you kind of go from left to right, you increment by that number, right? So that's kind of the idea. So then now if there's on a 0 index, so you go to 4, then this basically has a slope of 4 going up. If this number is 3, then it has a slope of 3 going this way. You know, this is index 1, 2, and you know, maybe the next one has an index of 5. So then what this means is, by the way, so then it goes kind of like this, kind of, not really, but what it means is that, you know, this is 0, or well, technically, I guess I messed this up a little bit actually. Let me rewrite this. So you have 0, 1, 2. So it's 4. So then now this is going to start at 4. The next one is going to be at 3. So this is starting at 3, but lower. The 2 is going to start at 5. So maybe it looks like this and then goes up, right? And what it means is, what I'm drawing the lines for is that this is going to be 4. After the next index, going to from 0 is going to be worth 8 and 12 and so forth. So the 1 is going to be a 3. So then maybe the next one's going to be 6, 9, and so forth. And then the 2, like I said, it's going to be 5. Okay, I drew this a little bit not according to scale, clearly, but like maybe the 10 is here somewhere, and then the next one's 15, right? Okay, so the idea here is that that I had, which is very complicated, but it's just, you know, ideas, right? Is that there are these crossing points in which it becomes better to take 2 instead of, you know, 0, right? So like in the future, you have some distances away. So here, I guess if, yeah, like I think the 10 is, it's actually a little bit. Yeah, it's a little. Let me draw over the 10 real quick, because I think the 10 is actually here, right? And then the 15 is here. So maybe I think this is actually a 16. So it doesn't actually cross quite yet. I don't know. But the thing is that from going from left to right, there is going to be like a point where it goes, you know, it's better to take the 5 over the 4, right? Because initially it takes the 4 over the 5, and then you have all these events. The idea then is that, okay, you start at 4 and then you kind of draw this line, because basically what happens is that what you want is that you have this line and then you kind of keep on going, and then you kind of almost like a let me redraw this real quick. But basically now the idea here is that, okay, so you have some lines like this, you know, maybe here, this one doesn't matter that much, this one, and then maybe that's too sloppy. Let me draw another, like maybe like this, maybe, you know, like this. And then the idea here about the optimal path is going to be almost in concept similar to a convex hull, right? So basically you just walk this stack to this point, I mean, you know, the integer version of it, and then kind of go up here, find this point and go up. So I was thinking about something along these lines, but what I realized is that yeah, so that's an idea, right? And in that idea, it's a little bit of a proof, or at least for me. I mean, maybe it's not a hard mathematical proof, but it is the seeding for what I did next, right? It is an idea. And you know, people ask me how I kind of play around with different ideas for different problems, and this is one of them. And the real idea for this particular solution is easier, but this is how I got there, right? Sometimes you have to be able to solve things in funky ways, maybe, but yeah, the idea here though, because okay, so the reason why I was thinking about that was that I was thinking about it in dynamic programming terms, right? Like I was saying, I'm not going to go over that much in detail, but because it can get very detailed even more than it already is, right? And make sure that okay, everything's on screen. So that basically for each index in this dynamic programming, let's say the 3, I wanted to see what is the best one to take from the left side. Now I was trying to figure out how to, and from that's how I constructed all these lines things, because I was like, okay, well, at this point, what is the, you know, like trying to figure out all these things to, what is the best place to jump from to get to here. And then it took me a while, but then the next thing that I got was that, okay, what if you think about it in reverse? And that's when things became a little bit more clear, which is that, okay, for each point on the left side, what is the next point that you can jump or you should jump to? And I think from that, there is this idea I have a and then I had a better visualization, which is that here, if we go from here, and let's say, so the question is, okay, what is the last index that 4 can end up in? And in this case, it's the last one, so it's not interesting. So let's actually add some numbers. I don't know, right? And it turns out and maybe make this a 5. And it turns out that the thing is that the next number that I should jump to apparently is 5. And the reason is because if you kind of think about it, is that, okay, you have this line that goes from 4, right? Go, and then you see a 5. That means that another way to think about it is that from this point on, we can choose to start at the 4 or continue with the 4, or continue with the 5 or start anew with the 5. And in that way, you always want the 5, because basically this is saying, like one space to the right, we want a 4 because that's the best thing, right? And then here we have a 5. I mean, we have to do the 4 first because we haven't had the 5 yet. But then now in the next cell, we go, okay, well, should we jump from the 4 or from the 5? Well, I mean, 5 is obviously more, so we want to jump from the 5, right? And then here we say, okay, do we want to jump from the 3 or the 5 or the 3, right? And of course we want the 5. And so I think I skipped a little bit about what I mean is that this is basically this function, and understanding this function is the key to this problem. And the thing with this thing is that it means that each space you move gives you num sub I points or whatever it is, score or whatever, right? So basically, because then now, if you keep the 4, you keep going, right? And then, so basically, if you keep the 4 and you end here, you're gonna have a 4, or you just here and get the 5 from 4 to 5 to get here, right? So then now, and then I was like, oh, okay. And then also combined with that visualization of that convex Hoey thing, I was like, okay, then that means that in here, in essence, all you need is just what's it called? Like an increasing sequence, right? So basically, in a greedy way, I mean, it's not. You can look at the solution and think of it as greedy because we always take the more optimal thing, but it is just that yeah, that's basically the idea, is that because you can decompose these things into parts, right? Because the question that, like, another way of thinking about it is, say, let's say we're here. The question isn't that we should take the 4 all the way here, right? So one way to do it is that we take 4 all the way here. This is, maybe I'm off by 1, but this is the visual representation of this formula that they give you, the scoring function, right? Because you have 1 4 1 4 1 4, so maybe we actually skip 1 4. So the answer isn't whether we should take it from here or here, right? Because that's what I was thinking of for a while, and I was like, okay, well, how do we decide where to go? But the idea actually is that, okay, to compare this with this, right? Because before the 5, we know that before the 5, it's going to be 4s, right? So that means that now we're comparing all 4s and all 5s, and now I think the visualization should become much clearer, right? Because then now this is the best path going to here, and then maybe the next 67 is a little bit weird, but or actually make this a 6, right? And then now in the same way, the question here, when we get to, say, let's say the 4 for now, right? The question isn't whether we compare, say, the right, or versus this, or versus versus, you know, this or something like that. It is actually something like, you know, we want to compare this with this. And once you kind of decompose it in steps like that, then it becomes more clear what you have to do. Is that every time you see a bigger number, going forward, you could carry that number 1 space forward instead for this function. And this is a lot of words and a lot of, you know, this is a 12-minute so far video to give you this really simple code that that people can type out in 2 minutes, and people do apparently very quickly. And yeah, you just kind of always go forward and carry it forward. But if you look at this, you may not understand it without all the kind of proper thing. And of course, this is kind of greedy because you always just take the more optimal thing, and it's going to be globally optimal, right? So the code is now, you know, maybe it's too late because I showed it for you, but with all the understanding, see if you can implement this by yourself very quickly. And if you do, then now hopefully you can compare to here, which is, just straightforward. We start with a score of 0. This is the max score from the first element. We add it to the thing. We add it to the score, because that score, you'll move 1 step, and then now we want to see what the next step is going to be, and it's going to be just the max score, right? So this is the rolling max, and that's pretty much it. Just kind of add it up. Of course, this is linear time, constant space, and this is all we have. I think I've said that this problem is easier than Q2. Honestly, I don't know. I mean, obviously, I spend more time here, so yeah. And the code is very simple, looking back, but the proof and the concept is a little bit tricky. There are a couple of ways to look at this and visualize this. So I don't know. Let me know what you think about this one. Let me know how you did. A lot of people got this one, so I don't know. I struggle with this one. So yeah, where I in Q4 it took me a little bit longer on implementation, but I knew what I wanted to do, and I was very confident about it, at least on the idea, right? So I don't know. That's all I have for this one. Let me know what you think. Yeah, and you should watch, or you can anyway, watch me solve it live during the contest next. Wouldn't be surprised either way, to be honest. Okay. Wasn't sure about that one, honestly. Oh, this one's easier, maybe. I don't know. More people got accepted, but that's not even true. Alright, I'm just a little bit slow. Alright, well, okay. How's Q4 doing? No one's gotten it yet, so we have some time. Maybe I'm just slow today, which happens. That one's a hard to read problem. Alright, let's go. Focus. Alright, start at 0 to reach jump greater than your current index C. So from left to right, I to j minus I times num sub I. So is this just dp? No, wait. I mean, dp will be n squared, but we want to maximize the score. So okay, so let's say we're here. So then it's so we want to maximize 1 times this, or okay, so every time we move to the right, okay, so it's, so let's say we're here, it's gonna be 1 times 1, or 3 times 2, or 4 times 3. And then we go to the next one, it's gonna be 4 times 4. How do we do the math that way? It's a monostack thing, right? Because is it? People are so smart to 60, right? Okay, how do we do it without incrementing? I guess that's what I want to know. A lot of people got this, so I don't know. And Q4, people got in it, so I'm really slow today. That's fine. But wait, what is the thing? Do we always want to just get the biggest number? No, because if this is 3, 4, then you have... So at some point 4 overtakes the 3. So greedy doesn't work. But... and 4 is slower on the thing. Right? I feel like this feels familiar, but I don't know how to do it quite, you know. So this is 3, this is 2. I mean, if this is bigger than this, then this has no chance. And now 3, this will always be bigger. Right? It feels like a monostack thing. Okay, so let's say you have 3, but then the 4, right? Okay, what if you have 3, 4? 3, 4, you have a 4, and the previous one is 6, and then 9, 8. Right, then how do you do the math that way? So it's 3, 4. Oh, it's not, maybe it's not monos. Is it mono Q? So a new number that's smaller than the thing is never going to cut it, right? And then now you want a bigger number. So then if it's 3, 4, then when do you pop off? And do you always pop off to the next one? Yeah, or is it like a segment tree thing? Or do I push? Then 3, so then now goes to the end, but that doesn't even make sense necessarily. Well, okay, now this is another way of thinking about it, is that, okay, 4, so we can I think it's some sort of greedy though. But so when do you stop? So the 3 we go to 4, but then okay, so you go to the next biggest number. So you keep, it's like a increasing sequence thing, right? Because any numbers that are bigger than the previous, you would never go back, and then you transfer. Okay, maybe that's why this is, people got it so quickly. Yeah, okay, fine. Score is equal to 0. Okay, so how do we start it off? So max is equal to num sub 0, right? Then for I in range from 1 to n, n minus 1 maybe, right? Because the last number doesn't really matter. And then if num sub I is greater than mx, then mx is equal to num sub I. But anyway, score we added by max, and then we just return score at the end. Something like this, right? 612. Maybe I have to do one more. Maybe that was one. $7.16. All right, let's go. YOLO. Yeah, I guess I did them in the wrong order, but okay. That's a hard proof though, the greedy, but maybe not. Maybe there's an exchange thing. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this video, everything in between. Yeah, and this problem, of course. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.